Hello, hi. Hello students, we are at AriserTalent and I'm your chemistry teacher. My name is Krina Dayani. So, we are on our chemistry chapter number 1, that is chemical reactions and equation, that is of our class 10 topic. So, until now we have discussed about lot of the topics like what is chemical reaction, what is chemical equation, what is symbol equation, and what are the limitations, specialties and the restriction methods for the rectification methods for any chemical equation. Now we have discussed about the type of the chemical reaction and I have shown you the categorization of the different type of the reaction. In this series we have slow and fast reaction, reversible and irreversible reaction, addition reaction, displacement reaction, double displacement reaction, exothermic endothermic reactions, and the last category of the reaction is redox reactions. So in our previous class we have already discussed about the slow and fast reaction. So I will give you a quick recap of slow and fast reaction. The reactions which take much time for their completion are known as slow reaction and they may take a month, year or some weeks. But on the other hand, the reactions which are completed on the blink of an eye, or I can say they are completed in few seconds, are known as very slow fast reaction. So this is all about the category of slow and fast reaction. Now today we will deal with our second category, that is reversible and irreversible reaction. So our second category of reaction is reversible and irreversible reaction. So according to this reaction, as the name indicates, reversible reactions are those reactions which can take place in both the directions, I mean forward and backward. On the other hand, irreversible reactions are those reactions which can proceed in only one direction. So firstly we will deal with what actually the reversible reactions are. So the reversible reactions are those reactions in which reactants combine to give product. Second point is they proceed in only one direction. So it is all about the reversible reaction. What we have discussed here is the reactions in which reactants combine to give a particular product, and these type of reactions can proceed only in one given direction. It means we have reactant on the one side, then arrowhead which indicates from reactant to products. So the simplified statement for reversible reactions are what happens in this kind of reaction. Suppose we have the two reactants, that is A plus B, and A plus B react with each other to give the product C and D. This is the reactant side and this is the product side. So in this type of reactions, reactant react to give the product, and irreversible reactions are basically indicated by a single arrow because the product will not again to form the reactants. Now we will consider a simple example for understanding this reaction. Have you heard about combustion of the carbon? Combustion of the carbon or coal means carbon react with oxygen to form carbon dioxide. So our next example is combustion of carbon, or we may say combustion of coal. Every combustion process will take place only in the presence of oxygen. So for the coal we have carbon. Carbon react with oxygen to give carbon dioxide. So this is carbon, this is oxygen, and the product form is carbon dioxide. So what we have observed in this reaction, carbon react with oxygen to form carbon dioxide, and we cannot get back carbon and oxygen from reverse reaction of the carbon dioxide. It means this reaction is proceeded only in one direction. So we may call it, these reactions are irreversible reactions. Now we will take another example for understanding the reversible reaction. We have second example, that is combustion of methane. So we have our second example. And the second example here is combustion of methane. So the students, we know that general formula for methane we have given is CH4. Now what will happen in this reaction? CH4 react with O2 to give CO2, and H2 gas is liberated in this process. So in the combustion of methane, what we will get here is, we will get carbon dioxide and hydrogen. So this is the general reaction for the combustion of methane. And what we have seen in this reaction is again proceeded in the one side. So we may call it, these reactions are the category of irreversible one. So this is all about the irreversible reaction. Now we are proceeding to our second set of equations or reactions, that is reversible one. So reversible reactions are just opposite to that of the irreversible one. In the reversible reaction, the reaction proceed in both the direction. It means reactant react to give the product, and at the same time product again react to give the reactants. So we have our second category, that is reversible reactions. So the main points regarding the reversible reactions are reactants react to give products, and the second point is products again react to give reactants. It means reactant react to give products, and the products again react to give reactants, and the reaction will proceed in both the direction. Reaction will proceed in both directions. So these are the main characteristics of the reversible reaction, that reactant react to give the particular type of product, product again react to give the reactants, and that these type of reactions will proceed in both the directions. So this is all about the reversible reaction. Now we will learn more example of the reversible reaction in our next. So before discussing it, if you want to copy it, please copy it now. So what will be the general representation for reversible reactions? So I am writing here about the general representation. The general representation for reversible reaction will be A plus B. We will indicate two half arrows, that is C plus D. Again, this side will be our reactant side and this side will be our product side. So these are the reactants and these are basically the products. Now what we see in this reaction, the reaction arrow proceed in forward direction and the other arrow is proceeding in backward direction. It means firstly reactant react to give the product and again the product will give the reactants. So it is considered in the category of two half reactions. And the two half reactions will be forward reaction and backward reaction. We have two half reactions. First reaction is forward reaction and the forward reaction can be represented as A plus B gives C plus D. So this is our forward reaction. Next, backward reaction I am writing here. We have second set of reaction, that is backward reaction. And the backward reactions can be indicated just opposite to that of the forward reaction. And the backward reaction will be C plus D gives A plus B. So what we have analyzed from the above two equations, that the reaction can be proceeded in both the directions. A plus B firstly gives C plus D and on the other hand C plus D again react to give A plus B. Now we will understand the reversible reaction with the help of an example. So our second category is examples. So we have taken the process of formation of ammonia. So we have our example, formation of ammonia. So students, formation of ammonia in chemistry is basically known as Haber's process. So formation of ammonia is known as Haber's process. So ammonia will be formed only when nitrogen react with hydrogen to produce ammonia gas. So the general equation for this reaction is N2 plus 3H2 proceeded in both directions gives 2NH3. This is the general representation for synthesis of ammonia. This is nitrogen. This is hydrogen. And 2NH3 is ammonia. Now what we have seen here, the reaction proceeded in both the direction. Firstly in the forward direction and again we can get N2 plus 3H2 after the decomposition of ammonia. So this type of reactions are categorized in the category of reversible reaction. One more point here to be noted is, in the reaction of N2 plus 3H2, the heat is liberated out and the heat liberated will be 22,400 calorie. So this much amount of heat is liberated in the process, and the processes in which heat is given out is generally known as exothermic reactions. So this is the amount of heat liberated in the formation of ammonia. So it is all about the reversible reactions we have discussed. We have one more example for the reversible reactions, I will show you. Firstly, you have to copy it. We have provided with one more example, that is reaction of nitrogen with oxygen. So our second example is formation of nitrogen dioxide. Reaction between nitrogen and oxygen. So what we have discussed here, that the reversible reactions can be proceeded in both the directions. So N2 plus O2, that is nitrogen and oxygen, react to give nitrogen dioxide or nitrogen oxide. So it is nitrogen, this is here oxygen, and both will react to give nitrogen oxide. So students, what we have observed in this type of reaction, that the reaction is proceeded in forward direction as well as backward direction, and it is indicated by the forward arrow and backward arrow. So we may say that these type of reactions are known as reversible reactions. So in the first case of the Haber's process of the ammonia, what we have seen, that the amount of energy or heat is evolved in this process, that is 20 to 400, and we have categorized in the category of exothermic reactions because heat is given out. These are exothermic reactions because heat is evolved in this process. Now, what happens in case of nitrogen and oxygen? The heat is taken. So, the amount of heat taken is 43200 joule. So, here the negative arrow indicates the heat will be absorbed in this process, and the positive arrow indicate that the heat will be evolved out in the given reaction. So the heat is given out. Heat is given out. So the heat given out in the process is basically known as endothermic reactions. This is endothermic reaction. So we have learned about the two categories of the reaction, that is what are reversible and irreversible reaction, and the second category of the reaction we are provided with endothermic and exothermic. In this short, we can say that the reactions in which the heat is given out is known as exothermic reaction, and the reactions in which heat is absorbed is categorized in the category of endothermic reaction. Exo means released, endo means absorbed. So this is all about our two sets of the reaction. Now this lecture is over for today. We will deal with many more equations in our next class. Thank you so much and have a nice day.